Hi, this is a video presentation of our research proposal. Our research topic is implementing probabilistic broadcast in decentralized file downloading system. I'm Yu Chen and my teammate is Zhao Long. In this video, I will introduce the application system design, literature review, choice of algorithm, and algorithm implementations. Let's look at the system design. In a decentralized file downloading system, there isn't a centralized server handling downloading requests. The node could be a personal devices like mobile phones or computers. Nodes could be download resources from peers. Before downloading from peers, the node will broadcast its request to determine which peer nodes have the resource. Any nodes having the resources will respond to the requester node. The response message piggybacks the estimating downloading time. The node will download the resource from the peers having the minimum downloading time. For this proposal, we review two literature. By reading chapter 3 of the book Introduction to Distributed Algorithm, we investigated 5 different broadcast algorithms and analyzed the advantages and disadvantages. We choose the probabilistic broadcast algorithm due to its relatively smaller network usage, but the trade-off is it's less reliable than the other four. We also reviewed the article called ARG, Real World Gossiping. ARG refers to actualized robust random gossiping. It is a robust gossiping implementation that could overcome many issues in a distributed broadcasting, such as node failure and unreliable network. We decided to integrate the probabilistic broadcast with ARG in our application. These are the pseudocode of two algorithms. On the left is the eager probabilistic broadcast, which is EPB. The node broadcasts to a random subset of all nodes in the system, piggybacking a round number for the remaining broadcast time this message could have. Which means if the message have the round number equals to 0, this message will not be further broadcast to the rest of the nodes. In the right is ARG. Each node caches a fixed size of living nodes and exchanges cache sets with the broadcast message sender every time it receives a broadcast message. Once the exchange happens, the node will union the received sets with its own cache, then drop excessive nodes randomly if the set is too large. In our file downloading system, node can join and exit the system at any time. So keeping a set of all living nodes is implausible for EPB. The cache set of living nodes in ARG could be an alternative for EPB to obtain a random subset of all living nodes. In simple words, the nodes will only send a broadcast message to the nodes in the cache sets, which also generated probabilistically. Let's move on to the algorithm implementation. Broadcast algorithm will be utilized in two scenarios. First is register. Each node will broadcast a hello message to the system so that some nodes in the system will cache this new node. Broadcasts were also used in node fetching the file from the system. In this scenario, node 1 requested to download the file 1 to 10 and broadcast the request message to all the nodes in node 1's cache sets, which are 2, 4, and 5. The broadcast message piggybacks a round number equals to the max round minus 1. In this example, node 4 will broadcast the message to node 6, since nodes 4 and 6 have files that node 1 requires. Both of them will respond to node 1. During this precise, every broadcast and delivery action will trigger an exchange and update of the cache sets of both sender and receiver. Both sender and the receiver will union the received sets from the other side and its own cache sets, randomly removing the sets from the union until it sets equal the maximum cached size, and assign its new set as its own cache sets. Such exchange and update of cache sets happens on every broadcast and delivery action. More detailed implementation and the purpose of this algorithm will be discussed in the final report. Thank you for watching.